All right, good afternoon. Project Lead the Way, Principles of Engineering. Today we're going to work on activity 3.1.1, inputs and outputs. This is your intro here. When you're going through this, you're going to split into groups of 4. When I say that, make sure you're in no more than 4, preferably groups of 2 or 3 working on this project. You need to go through and do the Intro to VEX Robotics Platform Robot C software. We're going to do that here. We're going to start with slides 1 through 16. Within your group, don't worry about the Team A and Team B stuff. We have enough equipment that I think everyone will have what they need. You're going to have to construct the VEX test bed. That's what this is right here. Give you an example. All right, that's there. And the instructions to do that are right here. Introduction to VEX. Introduction, no, not the platform. Test bed build instructions. All right, those are pretty straightforward, easy to follow. So we're going to go ahead and go over that. And then we're going to go into Robot C and how to start programming your stuff. But to start, let's go ahead and go through the Intro to VEX Robotics Platform. You'll download the PowerPoint, and we're going to go through that. And when we get to that, one second, I'm going to close the door. So we're going to go over that. Sorry about that. So this is the test bed that you guys are going to use. Stop shaking. This is the test bed you're going to use once you're done building it. Once again, follow the test bed build instructions. The structure subsystem, this is just kind of the skeleton that you use. It's all these brackets, things like that. We have different types of screws and different types of nuts. Nylock nuts, Keps nuts, and regular nuts. Here is the thing. These screws here, and listen up, because it's going to be a problem. If you tighten them too much, it will be really, really difficult to get off. As well as the ends of the screws here, they like to strip. So if you tighten too much, it will ruin the screw. What you need to do is basically tighten it till it's tight. You don't need to crank on it. It doesn't need to be super snug. It'll automatically tighten. You could pretty much tighten these by holding your finger on the screw and then just tightening the nut with your hand. All right, and that should work for the most part on most things. But you'll find that if you try to over tighten, you're going to strip out those, and then the Allen wrenches won't work on them. All right. Components that make the robot move, we have different things available to you. We have gears, which are the toothed items. We have the wheels, and we have plenty of different types of wheels. We have motors, and we have servos. We have 2 different types of motors, 269 and 3 something. The 300s are bigger than the 269s. The difference between motors and servos, motors are controlled by a speed, all right? So when you put in 60, it's like, all right, 60% speed. And they can continually rotate in one direction at a time. And then servos instead operate off of degrees, so you can only rotate a certain amount with servo. Typically, a servo is more used to like open a valve or open a gate continually. You're not going to use that for like a wheel to rotate. So here's the 2 motors like I was talking about, the 2-wire 269 and then the 393. All right. You have to connect your motor controllers, or you have to connect a motor controller to ports 2 through 9 when you use a motor, okay? So that's where your motors go. It has to have a motor controller, which is a separate device that attaches to the motor, and then the motor attaches to the VEX Cortex. Your servo, once again, different, but looks like a motor, and servo rotates between 0 and 120 degrees. These are all your different sensors. You have digital sensors and analog sensors. Digital sensors are your bump switch, limit switch, optical shaft encoder, which basically counts how many rotations have occurred, ultrasonic rangefinder, which is basically sonar. Analog sensors include light sensors, potentiometers, and line followers. So a line follower would be like if you put tape on the ground and you wanted to follow the tape, like a robot that would follow a trail. You could do that. Potentiometer is, for lack of a better explanation, it's pretty much the exact same tool that's used when you have a light dimmer in a house. All right, and then a light sensor can determine how much light is in a room. So if you wanted to do something like when it's too dark, automatically turn a light on, you could have something like that. Potentiometer, like I said, Cortex runs between values of 0 and 4095. There's an internal mechanical stop that will prevent you from making a full revolution. Do not torque against this. So turn it till it stops, but don't crank on it. Optical shaft encoder, once again, it counts 360 it has 360 counts per revolution, and it can count up and down, and the distance which a robot moves can be controlled by monitoring the angle at which the wheels attached to the shaft encoder spin. All right, so if you want to know guarantee that's going to move so far, then you could use optical shaft encoder instead to control like a motor to run instead of running for a certain amount of time, because if the battery's dead or dying, your motors are going to run weaker, so you may not make it as far. So having an optical shaft encoder, you can say run the motor until you get to count 486 or something like that, so it continually goes the same distance. Ultrasonic, once again, digital sensor returns distance values between 0 and 255 inches. And then if it's outside the range of a return signal is not sensed, then you'll get values of -1 or -2. So it has a cone field of view for the ultrasonic rangefinder, like shown here. Sensor detects objects distance from the center of the sensor. Things that may not be detectable are things that are soft that can absorb sound, sharp objects that deflect sound. All right, so those might not be the best. Your microcontroller is where all of your stuff plugs in, and this is kind of like the brain of your operation. Things plug in there, and then here's our stop point where we will return to the activity. So I'm going to go ahead and back out of that. I'm going to minimize, open this. So like it tells you exactly how to do this when you guys are going through the assignment. Okay, we finished that. Then let's see here. Construct the test bed. We're done with that. Start Robot C and Vex Robotics software. So to start your Robot C and Vex Robot software, okay, underneath your computers, all of you have a PL2W folder. And there is Robot C. Now there's 3 different ones. We have Graphical Robot Virtual Worlds, Graphical Robot C for Vex Robotics, and we have 4 different ones. Robot Virtual Worlds, and then we have Robot C for Vex Robotics. Do not click the graphicals, do not do the virtual world, make sure we're on Robot C for Vex Robotics. Alright, so you'll open that, you'll get this screen. We'll see, there might be a download. We'll see if it works. Awesome. If it doesn't, it should still work fine for you guys. So while that's going, we're going to go back here, connect the test bed to the computer using the USB cable. All right, so if you look at there, I have the orange cable plugged into the computer, and that is also plugged in to the test bed itself right here. Okay, and my current Cortex is off, and then I'm actually going to plug in a battery later on to get it to work, but we're going to put that back down, and your batteries look like this, and that'll plug into the Cortex. Okay, so once we get that up and going, we're going to go ahead and go back to our slides here and do slides 17 through 30. So Robot C software from the current slide. So this is the specifically designed for, no, it's not going to work. Robot C, verified publisher, I need admin, nope. All right, so just when if it asks for a download, make sure you guys select no, and we'll just continue with the version that we have. All right. So Robot C is specifically designed for this as a real-time debugger. A debugger window is basically if you have parts in your code that aren't working, it's going to help you fix those and kind of guide you towards having the right answer. So, and this is very similar to C programming, standard C. And these are your kind of industry standards. So you have Java, components of C programming are found in C++ and Java as well. So that's where we're at, as we're kind of in the middle between Java and C++. Other things, along with Eclipse and Visual Studio, IDEs have been used to program. So you have like Microsoft Windows, Mac OS X, things like that have been created using this similar programming language. So the first thing we're going to do is you're going to open Robot C for Vex Robotics, which is what we just did, and it's going to have a display right there with the latest news. So based off the version that we have updated, this was most recently updated still a while ago. August of 17 was when the last version was, but we'll see if we can get a new upload before you guys work on this. So we're going to change the platform type to Vex 2.0 Cortex, and to do that, the windows are there, it shows you how to do it, but I'm going to show you up here. So to do that, you're going to go up to Robot, and underneath Robot you're going to go to Platform Type, and you're going to change that from Vex IQ to Vex Robotics, and make sure you select Vex 2.0 Cortex. Alright, we're also going to change the platform type to natural language. So to do that, we're going to go back to Robot, we're going to go Platform Type, and down here, make sure we go to natural language PLTW. Alright, and then the other thing is you're going to have to do this multiple times. But there are over 75 Robot C sample programs organized by robot behavior. So to open a sample program, you're going to go up here, File, Open Sample Programs, and everyone's going to do this, and you're going to have to do it every time you start a new program. All right. So to do that, you open it, and then you go, where are we at? PLTW natural language. All right. So then it's underneath PLTW. You're going to do PLTW template. We're going to open that, and that's going to open the PLTW template for you. And one thing I recommend again is just go back and double check and make sure that your platform type is correct. 2.0, natural language, things like that. Okay. Next. So we're going to go on how to do this. So when you guys are typing in your coding window, all right, there are plenty of things you can do. The first thing is if you have a // like so, and then you type after it. So Mr. Richman is cool. All right. Anything after 2 backslashes is not going to be read by the computer. It's more comments for you guys to understand where things are. And I'm going to ask you to do this every now and then. So like, for example, if you were to write a program to run a motor or something like that, write motor, and we don't have the 240, I'm just making up numbers off the top of my head, semicolon. And then after that, you would, in the pseudocode, that's what the green stuff is, you would write, right motor rotates at 240. At 240. Okay, so that's just so someone who is unfamiliar with the coding language, they can understand what's going through. Or if you need to quickly go through, for example, imagine you're writing a huge program, it's got lots of lines of codes. It may be easier for you to have some pseudocode in there just so you can find where you're at. So once again, pseudocode is the stuff that's in green. And pseudocode is written in a way not for a computer, but you don't want it to be like a huge paragraph. So like say I needed a motor to turn on for 10 seconds and then stop for 5 seconds and then turn on for 10 seconds and rotate the opposite direction. All right, so I'm not going to make a huge long paragraph. I'm not going to write the code as well, but pseudocode is just to kind of give a paraphrase of what's supposed to happen. So turn right motor on for 10 seconds. For 10 seconds. Stop right motor. Wait for 5 seconds. I'm just making stuff up here. 5 seconds. And turn motor back on. Turning motor back on. Turn motor back on. Rotating. Opposite direction. All right, so that's just a very generic pseudocode example there for you. So once again, you have a debugger window. That window is down here, so when you guys actually start running code, it'll classify where there's errors. You'll have little marks that pop up in this area. So we have file, we've started a new project. All right, motor and sensor setup. So to set up your motors and sensors up here, you would click on motor and sensor setup. Make sure you have the right configuration selected to do that. You're just going to go to motors, analog sensors or digital sensors, and based off the information that you want it to tell, we will get into that later. So that's one way to do it. Once you upload those, it'll know what you're referring to later on. So you could name your motor instead of right motor. You could name it Betsy if you wanted to. Turn Betsy. Whatever. How programs are downloaded. Whether the Cortex looks for VexNet connection when it starts up, or the VexNet or USB option will result in the Cortex looking for a VexNet connection for up to 10 seconds before running code. So what we want to do is make sure that underneath Robot and underneath Vex Cortex communication node, we want to have VexNet or USB selected. Okay. Another thing you may want to do before getting too far into the weeds is just manually update the firmware. Okay, let's see what we have here. Anytime there's firmware updates, and you can always make it check first, just to make sure that everything is good to go. We're good. So that's the firmware, robot, download firmware, manual update, master CPU. You can make it check that as well. And then once it's through those updates, failed to enter. Okay. Oh, the Vex controller is off. That's why. So now would be a good time to plug in my battery. And once the battery is plugged in, I'm going to turn on my motor. Now I'm going to try it and see what happens here. Robot. Download firmware. Nope, not the joystick. I don't have a joystick. There we go. Sometimes you may need to unplug your USB and plug it in again, just to get it to realize that there's something there. Erasing VEX device, writing VEX device. So now it's erasing the old programming and updating it with anything. So Robot C releases new code that will help it read better and have less issues. So, alright, everything was downloaded correctly. So Robot C also has color coding. So if you look, you have keywords that are in blue. Intrinsic symbols are things like set motor power, or start motor, or stop motor, or turn flashlight on. Keywords would be like if-then statements, which we're going to get into later as well. Numbers are exactly what they sound like, numbers. Operators would be like equals and pluses and minuses, and then normal text would appear black. So there's all different types of colors, and that's that PowerPoint. So once you're done with that, we're going to go up through the setting, the motors and sensors. So we're going to select robot, platform type again, VEX 2.0, make sure that the VEX Cortex communication mode is VEXNet or USB. Very good. And all the instructions are what I'm reading right here. Verify that VEXNet or USB is selected. Select view and then communication port. So view, communication port. Verify that automatic selection is selected. Automatic selection is right there. Boom. Okay. Open the PLTW Robot C template. So I already did that, but we'll try it again. File, just so you guys get into the habit of it. File, open sample programs, PLTW. So to get there, it would come up PLTW, yeah, robot. Yeah. My goodness, file, open sample programs, PLTW template. Not, oh, it tried to compile. All right, let's exit out, and I'll reopen this just so you guys get in the practice of it. Where are we at? PLTW, Robot C. Okie dokie. So we're going to do robot platform type, VEX Robotics 2.0, robot platform type, natural language, robot platform type. Make sure all this is good to go. Okay, we're going to go here. Should be VEXNet or USB. View should be automatic. Automatic. Next, file, open sample program. Once again, PLTW, PLTW template. Boom. Now we're good to go. So we're going to do this, and you guys should do it as well. File, save as. Make sure you save on like your H drive or a flash drive. Preferably don't save it to the computer, because if your computer crashes, everything goes away. So for example, I'm going to save on my H drive. I'm going to call it, what's it say to save it? A3_1_1 rich man. Why not? Okay, we're going to save that as the project title. Complete the project title, team members, date, and the pseudocode blank. So pseudocode is where you would title it as like inputs and outputs, inputs and outputs. Team members, me, date, October 1st, section, POE, like but we only have one POE section. Task description would be like, what are we doing? Well, we're doing the inputs and outputs, like we said. So that's good. We're going to do robot and then motors and sensors setup. There's also a button right there if we want to do that. But motors and sensors setup, and we're going to set up those motors, all right, the correct way. So we're going to zoom in here. So to start, we have motors. In port 1, we have the flashlight. And I'm going to double check and make sure that in my motor ports that is correct, because I have a flashlight and it is plugged into port 1. So I'm going to call that flashlight, and I'm going to call it Vex flashlight. Boom, reversed. Make sure the reverse button's checked for that. Good. Now we have right motor. I have a lowercase r and then capital M for motor, all one word. Once again, whatever you guys name it is up to you, but you're the one that's going to have to remember what it's called. So I have a Vex. I don't have 393s. I went with the 269s. So make sure you have the right motor connected. Right motor, left motor. We're going to do that. That's also 269. And then port 9 would be the servo motor. Make sure that's 3-wire servo. Apply. Cool. I'm going to scroll down again. Vex analog sensors. Easy peasy to set up. Line follower. Line follower. Potentiometer. Light sensor. No spaces again. That's good. I'm going to apply that. And then my digital sensors. I'm going to do limit switch. That'd be a touch sensor. Bump switch, which is a touch sensor. Quad, which is a quadrature encoder. Okay, and sonar's digital port 5. Sonar would be sonar. And we're going to do this in inches. Second port is going to be underneath it. It's going to automatically create that other port. So you need to make sure that you do that. Now, if you don't plug in your quadrature encoder the right way, you just have to flip the leads later on. And same thing for the sonar. Since there's 2 plugins, and I don't quite know which one is which. So we're going to apply that. And then my LED, I'm going to put green. And Vex LED, apply. Okay. And I'm going to zoom out again. Get your teacher's approval. So have the sub or another student at least check. And I'm going to turn my Cortex back off. I'm going to power on the Cortex. Okay. Now it says view motor and sensor debugger windows. To select, and to do that, select download a robot. Okay. Download the robot. So it should compile the program, and it's going to install it on my robot. So now what that did is it took all this information and put it on my Vex Cortex, which is here. It put it on there. That way it knows what is what. So when I tell it right motor, it's like, oh, this is the right motor. Cool. Very good. So there's no program right now. I could click start, but nothing's going to happen. So next, click Robot, Debugger Windows. And to do that, I'm going to click on Robot. I'm going to go down to Debugger Windows. I want to make sure that I see everything like motors. Go back here, Debugger Sensors. and later on you probably want to see timers. Debugger windows, timers. And all that stuff pops up down here, and to switch between those tabs is like compiler errors, global variables, local variables, motors, sensors, timers. Okay, so those are all things there. So for example, I have motors here. I'm going to compile my program again, download the robot, and then if I want to see the stuff in my debugger window, you won't see anything here, but now I'm going to click start, and all of these populated. So like flashlight, right motor, left motor, servo. If I go to my sensors, alright, here's my line follower. Okay, it says 3040, and my line follower is right here. And if you look at that number, now it's like 1100. It's the top one. Again, it keeps on changing. The potentiometer is like stuck at 113, 114, but now I move it, it's like 900. Alright, so we're getting stuff. That's good. So you create the sensors tab, increase the debugger window, start, verify our motor output. So now we're going to check our motors. Alright, and here's one thing I would recommend doing as you guys build. Check your motors first before you actually bolt them in to your test beds or your projects later on, because I did not. So like, say this motor is broken, all right, we'll figure out if it's broken, but if it's broken, then I'm gonna have to tear that off again to get to the next part. Whereas if I would have tested beforehand, I could just make sure I install a good one to start. So what we're going to do is we're going to click the Motors tab at the bottom on the window, Motors, all right, and here it says click port 2 under the power column, which would be my right motor, and it's saying let's enter in several values from 127. So I'll click on that number, I'm going to write 127, why not, and boom, my motor's turning, and that is turning counterclockwise. So now if I turn that to negative 127, oh, it is turning clockwise. Alright, so that's a good motor. We're done with that. Cool, so I'm going to go back and hit 0, and it turned it off. So that's how you check things. And we're going to do that for port 3 as well. Left motor, 127. Cool. You can hear it, I'm sure. And then negative 127. Easy peasy, right? Half speed, 60. 30. 10. Not enough. So the resistance is too much with 10. Maybe 20? Very slow. Maybe we can go slower. 15. Pretty slow. Maybe I can go with 12. That's super slow. That's about it. 13. Yeah, so we got plenty of different variables that work. I'm going to stop it. Observe the line follower, observe the potentiometer. Alright, change those. I already did those. Verify digital sensor inputs. So now I can look at the digital sensors. And so for example, let's look at the limit switch right here at that number. Okay. Currently it says 0 because digital sensors communicate in zeros and ones. So when I hit that, it should, my limit switch should change to 1, and it does. 0, 1, 0, 1, 0, 1, bumps with 0, 1, 0, 1, 0, 1. Okay, so you're just going through this PowerPoint basically. Observe the optical encoder sensor. So, and I rotate that. My quadrature encoder says negative 26. I'm turning it counterclockwise. Now it says like negative 160. I can go as many rotations. I can go back the other way to get positive numbers. So that works out pretty well. Change the green LED light value. Once again, that should be a 1, so if I hit 1, and my LED lights up. There it is. And then I will turn it off. 0, and it's off. And then I can turn it on again. 1, and then on. So, works out fine. Get your teacher's approval before proceeding to the next step. So, changing the servo's value as well. I'm going to go back to my motors, check my servo. To turn on my flashlight, that's the same. 127. You gotta make sure your flashlight's on to start, otherwise it doesn't work. And for some reason, I don't know why I have this, but it's reversed. So like I put a negative 127 and now the light's on. If I put a positive 127, the light's off. If I put negative 10, it's less light. Negative 50, more light. Negative 127. Alright, so things are going to change. So flashlight's working well too. Team B, once again, not Team A, Team B, everyone should have this. So if I put over my sensors again, I have my sonar right there. Currently it says 86, and now I'm holding my hand over it. So here's my hand, and as it's getting closer, I'm lowering my hand to it. Now I'm going to put that on the screen again. So my sensor's here, okay? And as I go closer, alright, so your sonar's working, that's fine. I'm going to turn off my flashlight. Light sensor is also working, I think. Where's my sensor? Light sensor. 869. Put my finger over it. And, oh yeah, good. You're getting good readings. So don't worry about that. But this is the first one, so make sure everything sets up great. And once you have that done, you've completed 3.1.1, and that's just getting everything set up for your test bed. So good luck, and with that, toodles, y'all.